In this video, we're writing Quicksort using Python. The earlier videos in this series explain the Quicksort algorithm in more depth, but here's the basic idea. To quicksort some array, first choose a pivot, then partition around the pivot, and as you partition, find out the final position of the pivot. Quicksort to the left of the pivot and to the right. Because it's recursive, we know we'll need some kind of base case. Continue through all the recursive calls, and the whole array gets sorted. We'll first convert this pseudocode to Python, and then make a different function to partition. Now this animation represents a finished quicksort, but we're not there yet. So let's get started. We use def to make a new function, and of course our array is the first parameter. Let's just call it array for simplicity. What other parameters do we need? Our recursive calls below give us a hint. We'll call quicksort on smaller subsections of the array, so we need a range to know where to start and stop. Call the starting point low and the stopping point high. Now whenever you use a range you have to ask, does this range include the endpoints? It seems like low ends are almost always included, but it's a convention in Python to not include the high end within the range. However, the quicksort code reads more easily if we do include the high end in the range, so we'll include it here. That's something you'd want to note in a comment. I'm not doing that here to save screen space. Just remember, when this code is finished and you're calling it, it'll look like this. Note the -1. That'll give us the index of the last item, which is included. Now let's write the base case. We need to answer the question, when are we finished? So could a subarray like these three on the left be considered finished? No. This? Still no. How about this? Yeah, that one's finished. One element counts as sorted. What about with 0 elements? Yeah, that's also done. So just using high and low, how can I tell if there's only one item in the range? Remember that we're including both ends within the range. High and low would be equal, and the range is just that one item. How would I know if the range is empty? With a range that's inclusive on both ends, an empty range will be shown by high being less than low. So use this. Now if this condition is true, we're finished. We return, but we don't return anything, because this quicksort function changes the array in place. Now let's update our two recursive calls to match our function's signature. Each recursive call will have 3 arguments, just like in our function declaration at the top. Let's visualize which parts of the array these recursive calls will work on. For both of these calls, the first argument is the same array, since that's still what we're sorting. The other 2 arguments are integers. They give the start and end of a range. To quicksort what's left of the pivot, where would my range start? It's 0 here, but we'll eventually be calling this on the left side of ranges that don't start at 0, so use low. Now for the high end of the left side, remember that the item at the index we give for high end will be included in our range, but for the partitioning method we're using, we won't include the pivot. So what exactly should go here? It'll be final pivot position -1. For the recursive call on the right side, where would it start? Again, don't include the pivot itself. One element after the pivot is just going to be final pivot position +1. And does it end at high or high -1? Recall that we're including the high end, so it'll just be high. Now, let's go back up to where we choose the pivot. My pivot choice video explains what the choices are and why you might use or not use each one, so check that out if you're interested. The middle element works well enough as pivot and is simple to code, so we'll use that for now. But this is a good thing for you to refactor later to explore quicksort more. The middle of a range is just the average of the endpoints. However, if you code it like this in Python, you're going to get a crash. Who knows why? It's because Python will automatically convert this to floating point division, and you'll end up with an index of 7.5 or something like that. It wants an integer index, not a floating point. So, just double the division sign to force integer division. This chops off anything after the decimal point to make an integer, so that we always get an index we can use. Then, we partition. The partition code is the tricky part, so we'll write that separately in a second. For now, we only need to know what parameters to send into partition. To partition, we need the array, so that goes in. And partition has to know which section of the array we're looking at, so low and high go in as well. I'm also going to send in the index of the pivot we choose. Now you could calculate the pivot index inside the partition, but I'd like to decouple pivot choice and partitioning. This will let you try out other ways to choose the pivot more easily, perhaps by parameterizing quicksort to take in another function that chooses the pivot. One little thing to clean up. I'm not crazy about the variable name pivot index, since it's only the index of the pivot before we partition. So let's rename this to initial pivot position. And that does it for the main quicksort function, the easy part. Now let's code up the partition function. So this is going to be Lomuto's partitioning scheme. I covered Lomuto's scheme in the first video in this series, and we'll start with the pseudocode from that video. If you already watched the first video, I want to say thanks. So this first line is already almost done. We've got our parameters, and all we have to do is change this to a def. I also like renaming this to initial pivot position for the same reasons I just gave. If you want, you can add type hints here. It's not needed for the code to run. This next line swaps the pivot to the end of the range. Given the pivot index, how exactly do I refer to the pivot? It'll be array, square bracket, initial pivot position. And the last item, since we decided to include the high end within the range, is just array, square brackets, high. And in Python, swaps look like this. I've always liked the Python swap. My first language was C++ back in the day, then lots of Java in college, and you either had to make a third variable to swap or do the old school XOR swap. And then I found Python. I'm like, yes, this is so much neater. This is the way that swapping should look. And so the form for swapping in Python is just a, b equals b, a. Remember that, we'll be using that again. This next line is good to go. On to our for loop. We'll loop through the items using an index. I'm going to call this, surprise, I. Everybody's comfortable with I for loop variables, so we'll just use that. And I is going to be in a range that goes from low to, where should we go to? Do we need to process the last element? So to remind you, this green item on the right is the pivot. We compare the pivot to everything else. We don't need to compare the pivot to itself, so we don't include high in the range. But the range function in Python doesn't include the high end, so if we use high here, it gets us everything but the pivot, which is exactly what we want. Next line. To refer to our current item, we use array brackets I, and this rectangle shows the current item. Our pivot will be array brackets high. Other code I've looked at makes a variable called pivot above the loop, and that's fine if you want to do that. When the if is true, as it is here, we get to do another swap. Our next line already looks like Python, so move on. These animations show the for loop running. After the loop exit, there's a swap, which you already know gets coded up like this. Our array is now partitioned, with the pivot between the lower and higher items, and we return final pivot position, so our quicksort function knows where to do the recursive call. And that's it! Combine this with the main quicksort function we wrote earlier, and you're off to the races. Here's all the code with some highlighting added. If that's too small to read or you're looking for something to copy-paste, check the top comment on this video for text of the code. I'm happy to answer any questions you have in the comments. And please, let me know what you think of these quicksort videos. I'll make more if people like them. Thank you for watching, and I'll see you in the next one.